Welcome back to learning program Cisco Networking with Rajput. Today we are going to have a look at BGP Peer Group. Peer Group is a mechanism to reduce number of lines in device configuration, and it helps network administrators a lot. You need to define all the common parameters in single peer group and then call that peer group with the neighbor. These common parameters can be almost all the parameters which we can use with neighbor statement. Updates are generated only once per peer group and then replicated to all peer group members. This is really important. Updates are generated only once per peer group and then replicated to all the peer group members. It ultimately results in less CPU utilization. We must configure same outbound policy for all peer group members. Inbound policy can be per peer basis. So let us review the configuration for BGP peer group. We go in router BGP configuration process and then neighbor and then peer group name and the peer group keyword. And then we define all the parameters within this peer group. So let us go and check the devices. Okay, we are going to use these four devices, router 1, router 2, router 3 and router 4, and we are specifically going to have iBGP peer group, and we will use multiple parameters to be configured within one peer group, and then we will call that peer group in BGP peer configuration. So the subnet configured between R1 to R2 is 12.1.1.0/24, and between R1 and R4 it's a 14.110/24, and on router 2 fast Ethernet 0 by 0, this goes to router 1. It says 12.1.1.0/24, and another one which goes to router 3, it's a 23.110/24, and router 3 it is 34.110/24, and on this one of course it's a 14.110/24. Loopback 1 interface on all the four routers is advertised in IGP, and we are using ospf as the IGP. Loopback 2 on all the four routers is reserved to be advertised only in BGP. So let us go and check device configuration. Okay, these are two physical interfaces, two logical interfaces. I have already configured ospf on all the four routers. Show run section router ospf. So I have advertised loopback 1, fast Ethernet 0 by 0 and fast Ethernet 0 by 1 in ospf. In the same way, on router 2 as well, or not BGP, it should be ospf. BGP is not yet configured. Loopback 1 interface and fast Ethernet 0 by 0, and then it's a fast Ethernet 0 by 1. Let us check. We have adjacencies. So IP route ospf. Let us try to ping one subnet. Ping 3. Okay. Check on router 3. So run section router ospf. Again loopback 1. Fast Ethernet 0 by 0 and fast Ethernet 0 by 1 subnets are advertised in ospf. Same here on router 4. Loopback 1. Fast Ethernet 0 by 0 and fast Ethernet 0 by 1. Okay, let us start configuring iBGP on starting with router 1. Conf t router BGP 100 neighbor iBGP peer group, and it's a peer group. So this is peer group name. We can define any name we like to. So and this the keyword peer group defines that this is the peer group we have defined. So now we need to define or specify all the configuration statements we want to apply on our neighbors, like update source, loopback 1, and then next of self, timers 30 seconds for keep alive and 90 seconds for hold down. Timers password Cisco, remote is 100. So this will define all the neighbor 2.2.2 peer group, three dot three, and 4.4. Now network statement, what we want to advertise from this router. Let us use a trick to fastly configure our devices to show history. We will make the changes what all we need to. I'm preparing configuration for router 2's perspective. So neighbor will be changed and that's it. Let us go and configure router 2. Let us make the changes for router 3's perspective, and this will be 2.2.2. Okay, for router 4's perspective, and the neighbor will be 3.3. So if we want to have a look at configuration which we need to apply for router 4, this is the network statement we want to advertise, and these are the neighbors we want to have iBGP peering with. So router 1, router 2, and this is router 3's IP address. Let us go and configure router 4 as well. Okay. Okay, so we can see BGP Summary, and we see all the three neighbors are up now, and the configuration we have. Okay, these 5 lines we have clubbed together in one peer group, and then we call that peer group for our neighbors. And if we do not use peer group, then you can imagine that these 5 lines will be replicated for all the 3 neighbors. So that will be repetitive work, and it's really nice to work with peer groups. Let us see another benefit of peer groups. Debug IP BGP updates. What real beneficial thing for device perspective is that updates are generated once and sent to one peer, and then the same update is replicated to all the peer members. Let us see. Let us make change on router 2 and shut down its loopback 2 interface. Okay, we shut down router 2's loopback 2 interface, and this route is withdrawn and it's removed from the routing table. See, the important thing is update group 1 222 updates replicated to neighbors 3.3 and 4.4. So what exactly happens? It just generates one update and then replicates the same update to all the peer members. It doesn't require to generate update messages for all the peer members separately. So that really helps to reduce or to cut down the CPU utilization. This is all about BGP Peer Group. If you find my videos informative, please don't forget to like, share and subscribe. Thank you for watching. Hope to see you again.